All right, I apologize for having to go into video 2. That first one was a little long, but that's because there was a couple pure math things in the beginning, just for your information to kind of see where these develop from and why. So hopefully, after the last video ended, you gave the try to this one that I was trying to get you to try right here, the you try one. If not, pause the video now. And now I will reveal the answer to see if you did it correctly. So let's take a look down here. And again, can't really see because it's off screen, so I'll move some stuff for you. I start here using the log cosines we just talked about. You get an r squared value. You take the square root of said r squared value, and you should then be able to identify what your answer is, which apparently, according to this, is, nope, I don't need to move that screen. There it is, about 3.4 kilometers. So again, this angle was between the two sides, so the angle drops in your cosine. You square the two sides, add them up, subtract twice the difference times that cosine, and don't forget to square root at the end. So here we go on to finding angles with the log cosines, because now we looked at the log cosines to find the length of a missing side, but we could be stuck missing an angle. And we might want to find an angle, like in the very beginning, where we had, if we knew three sides, how do I find the angles in there? So I'm going to rewrite the log cosines. This time I'm going to use slightly different letters. I'm going to use c squared, which means if c squared is the side that's missing, then I would know the sides a and b. Again, it doesn't matter what letters you put in here, just these are the other two sides, minus 2 times the other two sides, and then this would be cosine of c. Again, that angle and that side are the ones that are on the two sides of the equal sign. So if I'm interested in finding what the angle measure is, that means I'm going to solve for cosine of c. So to do that, I would have to move these two things away first by subtraction. So I'm going to do it down here. I'm going to have c squared, and I'm going to have to subtract a squared and b squared. So minus a squared minus b squared equals negative 2ab cosine c. Now, I don't like a negative here, so one thing I can do is I can multiply this entire equation, every single thing in it, by negative 1, because I don't want to deal with this negatives. Otherwise, I could add this over and then do the opposite of each of these. But if I just multiply everything by negative 1, that means this c squared is going to become negative, and these are going to both become positive. So I'll end up with a squared plus b squared minus c squared. And again, that negative 1 would make that negative, plus, plus, and it's going to make that a plus. And that's what happens when I hit that in there. So that would equal 2ab cosine c. And again, if I'm trying to get cosine c by itself, I'm going to divide both sides by 2ab. Officially, that should come all the way over here. Divided by 2ab. There it is right there. And so these would cancel. And so the angle I'm looking for would equal the two sides that are not opposite squared added together minus the side opposite squared over 2ab. Again, these letters are interchangeable, but the fact that this angle is the side that's being subtracted squared is what's important. This also is part of the log cosines, and we're going to use it in a minute to solve for a missing angle. So again, on the formula sheet, so I don't think you need to worry about memorizing that formula, but it's good to know where it comes from. So I seem to have gone a little too far, so here we go. Again, this is the angle that apparently is in question. So I'm going to write down the formula, which conveniently works exactly like I just wrote it on the prior page of notes. So cosine of c, because I don't know that angle, equals a squared plus b squared minus c squared, side matches with that angle, over 2ab. And now I can start trying to figure this thing out. So cosine of c equals, so this would be a, so 8 squared plus b 5 squared minus 7 squared all over 2 times 5 or 8. I guess it doesn't really matter, does it? We'll make that an 8, 5. So if I calculate all this in my calculator, make sure this entire top portion of this fraction or ratio over here is calculated as 1 before you divide by 2 times 8 times 5. Again, that's an 8. And if I were to do all that, this actually ends up equaling 0.5. If you were to calculate all that, you get 64 plus 25 minus 49 over 80. That equals a half. And how do I figure out the angle? That's where I just use my inverse trig functions on my calculator. So C is going to be cosine -1 of 0.5, but you may remember when cosine is equal to a half as well from back on the unit circle, and that would equal 60 degrees. So your answer here is 60 degrees, and if I wanted to, I could now use the law of sines to find angle A or B, or I could use the law of cosines to find one of the other missing angles. Law of sines is usually a little bit less punching in your calculator, but you get the same result either way. So once again, this video is going to be much shorter than the prior one. You try using this triangle to figure out the obtuse angle PQR, which is right here. Notice then that that is the side across from it, and that's important. These are the two sides that include it, and that will help you calculate it. So take a second, pause the recording, and once you're done, which I'm assuming you are because you started playing again, you can now verify your answer to that problem. I went one page too far. In this one you can kind of see everything except for that my face is in the way, so I'll pull everything up. If I want Q, notice that I'm talking about 5 squared plus 7 squared minus 10 squared, and that's over 2 times 5 times 7. You get that answer. It's negative. I'm not freaked out about it because that just means I'm going to have an obtuse angle. Again, thinking about your old trig values, put you in the second quadrant. That's not a big deal. And once you do your inverse cosine, you get 111.8 degrees. And that is the end of part 2 of the notes. A little bit quicker because it's just more faster examples. Hope that helped. You give them a go, and we'll see you next time.